today I want to play my new favorite game, Super Mario Quadratics. The game was created inside Desmos.com, a free online graphing calculator, by a math teacher named John Rowe, and somehow it got retweeted into my timeline, and I couldn't be happier that it was, because I love it. But before we play, let's fuel up on gamer knowledge. When Mario jumps, in fact, whenever anything jumps, whenever anything is tossed into the air here in Earth's uniform gravitational field, the path it follows is the shape of a parabola, which means it can be described by a quadratic function. A function is just a mapping between an input set of numbers and an output set of numbers, such that every number in the input set connects to one number in the output set. Now, if there's a rule that allows me to easily, when given an input number, tell you which output number it's connected to, that's awesome. And that rule might be, for example, take the input number and double it. So if you give me 2, I know that the 2 in the input set connects to, what is 2 doubled? 4. It connects to 4 in the output set. 10 in the input set connects to 20 in the output set, and so on. Every single one of those pairs, 2, 4, 10, 20, 100, 200, that entire collection of pairs is the function itself. Here on my screen, I have an equation, y equals x. If y represents numbers in our output set and x represents our input set, then we can actually create two axes. This horizontal one is an x-axis, and this vertical one is a y-axis, and we can plot all of those pairs of points and create a beautiful line in the case of y equals x. Y equals x means that if you give me an x, an input value of, say, 3 right here, I know what the output value will be. Since y equals x, the x value being 3 gives us a y value of 3 right there. Boom. Whoop, I hit 3.01. Right there. Boom. That was 2.99. Right there. 3, 3. That ordered pair is in our function. But look, we're not here to talk about just any old function. We're here to talk about quadratic functions. So let's raise x to the power of 2. Boom, a parabola. Here, every value on the x-axis is paired with a value on the y-axis that equals that x value squared. So what is 2 squared? 4. 2, 4, boom. Oh, almost made it. Yeah, there it is. But what is negative 2 squared? Well, that's just 4 as well. So negative 2, 4 is also in the function. You might notice a problem here. This does not look like a path Mario would follow when he jumps. We might need to transform this graph a little bit, and that is exactly what Super Mario Quadratics is all about. So let's talk about how to transform the shape and position of a parabola on a graph. Let me, first of all, try to shift the parabola up and down. Right now, its vertex is at 0, 0, where x equals 0 and y equals 0. But if I wanted that to be higher, it really wouldn't be that difficult. I would just add a number here, because y equals x squared. But if it equals x squared plus 1, hey, I've just shifted the whole parabola up 1 unit. You give me an x, say 0, I square it, still 0, but then I add 1, whoop, and we've got 0, 1. Okay, but what if I want to move it down? Well, it's actually, I think you're probably way ahead of me. Just subtract. Now I can move it down. I can move it down 1. I can move it down 8. I can move it down just half a unit. Not too shabby. But what if I want to move it left and right? Well, now I have to change something about the x value that I'm putting in. Before I square it would be ideal. So take a look at this. If I don't just make y equal to x squared, but instead decide to do something like adding 1, hey, look at that. If I add 1 to x before it's squared, the whole parabola shifts to the left. So it goes, its vertex, in fact, every point moves in the negative direction. And that's because now whatever x value I give you doesn't just get squared. Instead, the value 1 above it gets squared, and that becomes the y value. So to get, for instance, y equals 0, I need an input value, an x value, that is such that when you add 1, its square is 0. And that would be -1 for x. -1 plus 1 is 0, squared is 0. Okay, so adding to the x brings us to the left, which means, let's just check to make sure, subtracting from x brings us to the right. Beautiful, perfect. But now let's make the parabola fatter or thinner. If I multiply x squared by a number, it will become larger. So imagine this point right here, 2, 4. And by point, I mean ordered pair. If I say that y is equal not to x squared, in this case x is 2, but instead to, say, x squared times 2, then this value wouldn't be 4, it would be 8. Every value is going to be larger, which means the parabola will become thinner. It'll grow a lot more rapidly. So let me just do that. Let me put a 2 in here. Ooh, let me put a 3. Yikes! Whoa! Actually, let me have a lot of fun here. I'm gonna make a variable. I'm just gonna call it c. I'm gonna add a slider. And now I can choose whatever value I want to multiply x squared by. Here it's just 1, so it's just x squared. But if I make c larger, the parabola gets thinner and thinner and thinner. And if I make c smaller, less than 1, it gets fatter. Whoa! Did you see what just happened? If c becomes negative, every value reflects around the x-axis and the parabola is now upside down. This is a beautiful discovery because this looks a lot more like Mario's jumps. Mario doesn't jump like that, he jumps like this. So we want this inverted parabola, and we can do that by just making the y value, when given an x value, negative whatever x squared would be. I think we are ready to Super Mario Quadratic. So here's the tweet where John Rowe announced the game, and I was actually waiting a long time for this to come out. I had seen little teasers of how it might work, and I was like, all right, I gotta play this. As you know, I'm kind of a gamer, and when it finally came out, I was all over it. So here's the game. Let's start with just World 1-1. Beautiful, so here's Mario. We want him to catch that coin. And the rules of the game are that Mario just runs along the ground until he reaches this dotted line, which is our parabola. And at that point, he will jump and follow that path until it intersects again with the ground, and then he'll continue on with the ground. So let's say I do nothing and I keep this equation the way it is. If I have Mario jump, he's going to not make it all the way to the coin. All right, so let's reset and think about this a bit more. I want this parabola to go up a little bit higher. And as you can see, its vertex is already at 1. So I need that to be at 6. Oh, look. All we need to do, of course, is add a number. So let me, instead of adding 1, add 6. Piece of cake. So I don't want to make Mario jump just yet. I want his jump to be even more radical, which means, for me, I want his jump to be steeper. And as you can see right now, we're multiplying. We have a coefficient in front of the x of -1. But if we make that number bigger, the parabola will be skinnier. It'll be steeper. The numbers will change more quickly as we choose, as we run through choices of x. So let me make that negative. Should I make it -10? Okay. I don't care. My mom isn't gonna watch this. -20. Yes. Okay. Do it, Mar. Yo. I call him Mar. And as you can see, the coin is spinning, and I get a next coins button. What I love is that there isn't like a specific equation you have to put in. As long as you reach the coin, you get to move on. All right. Ay caramba, this is gonna need a fatter parabola. Do you think -1 is enough? Ooh, no, we need something a little fatter. Is 2 enough? Oh, well, no, 2 makes it thinner. I need smaller than 1. How about 0.5? Some call it luck. I call it the game zone. My brain's always in it. Jump. Let's see if this works. Nailed it. Nailed it. No big surprise there. Ooh, trying to throw me a curveball by moving the coins to the left. I know how to move a parabola to the left. I need to add 2x before it's squared. So instead of subtracting by 10, let's only subtract by 5. Actually, it looks like 7. There's a convenient there are units along the axes. So let me try 7. Oh! Somebody's a genius. And it's all of us. Because when you learn, we're all winners. Let's move on to a different world. Here's, ooh, World 1, 2. Ah, now here, we need to jump over the lava. And the parabola, as it already exists, is well, it needs to be inverted. So we already know that we need to make this coefficient in front of the x negative. Now we need to raise it up to, it looks like about 10. And we raise it up by adding 10. Perfect. And then I need it to be shifted to the right 10, which means subtracting 10. Oh, it's not fat enough, is it? Mario's going to fall right in the lava. So to do that, we need to multiply by a smaller number. So the coefficient should be maybe negative 0.1? Oh! I've only played the first level. I wanted this to all be a surprise, but when you're as good as I am, no game's a match. Okay. 5th world, 6th world. Give me some kind of new challenge. Ooh. These are looking... Wait. Bowser has the princess locked in the room. You need to defeat him to unlock the door. There's a button. Defeat Bowser. Yeah, okay. I'll just click the button. Oh, that just launched the puzzle. Okay. Enter a quadratic below to jump onto Bowser's head until you have defeated him. Okay. So... Oh, I wonder if I land on him with more force if I jump higher. Well, let's try y equals. I know that I want this to be negative because I want to jump up and come down. So I'll do negative x squared. Okay, but I need to shift this on the x-axis to the right. So that means subtracting, and I'll subtract like 10. Perfect. Okay, now I want to jump up nice and high. So let's add, let's add 8 so I wind up at the top of the page. And then I need this to be fat enough that I actually land on Bowser. So let me try making this fatter by using a coefficient of 0.5. Not really enough. How about 0.3? Yeah. Let's see what happens. Pew! Oh my gosh. Now, I knew math was fun, but I didn't know it was... Wait, did I win? Is he going to stop spinning? Change equation. Oh, okay. Now it's time to go again. I'm going to do what's called a pro gamer move. I'm not going to even make a quadratic equation. I hope it doesn't break the game. I hope it doesn't mean that I forfeit because I'm cheating or something. But watch this. Instead of squaring, I'm going to raise x minus 10 to the power of 3. Ooh, look at that. That's a pretty cool dive bomb move. I'm going to shift this thing back a little because I want to hit Bowser. Plus 1. I think that's going to be good enough. But you might say, you know, Michael, what I don't understand is that Mario... Wait, if I start from here, what happens? Ooh, it doesn't... Oh, dive bomb. So Mario just starts at the beginning of your function. Oh, wow. So I could choose all kinds of things. Let me do y equals sine x. Yeah, okay, but I want to actually hit him. So let me, I don't really know how to change the sine function, but let me, obviously, if I just like subtract 1, oh, that moves it down. Okay, perfect. So let's, ooh, wait, what if I did, what about the sine of x squared? What does that look like? Oh, yes. Okay, this is going to be good. I'd like to rotate it. I wonder, is there a way to rotate this? What if I multiply it by another sine function? Ooh, that looks pretty sweet. But it's not hitting Bowser. So let's move it down a little bit. I'm going to just take this whole equation and I'm going to subtract 3. Yeah. Start. Oh, go through the door. Okay, so not using a quadratic was kind of a super move. I think I'm ready for the 9th challenge. Mario, help me. Save the princess. Now look, okay, this game obeys mathematical rules. Like, I could just put in y equals like 6, and I get a straight line, and Mario just follows the straight line and reaches the princess, and like I've won. But that's not fun, is it? No, not at all. What we want is to have some fun and collect that star. Or do we? Let's try another weird function. By weird, I just mean not a quadratic. What if I do tangent of x? That's going to give me, ooh, I wrote this all wrong. Tangent of x. One thing that this helps you do is you really learn how to properly use notation, because you have to, and you see the results immediately. If I just have Mario follow tangent of x, whoa, hey, that worked. It was actually Luigi's voice. What if I did this? What if I had y equals, okay, x, but I can do a piecewise function. So I can say that from, for x is less than 6, y equals just x. So now you see there's this little dotted line there. That means that the output value, the y value, is just equal to x up until we reach x equals 6. I might go a little further than that. Let's try 8. Oh, what? Not 89. Okay, beautiful. Now, let's say for x is less than 14, I want the function to simply equal 8. So now it'll be a straight line. Then for x is, let's do, I'll actually do a parabola. I'll do a quadratic right there. For x is less than 14, y equals, well, let's just put in x squared and see what that looks like. To put a little parabola here, we need it to be shifted 16 over. So I need to subtract 16, and then I need to raise it up 10. So that means plus 10. Now where is it? Oh, that squared should not be on the outside. I'm telling you, this is like the best way to learn how to do proper notation. Okay, so I want this to be for x less than, not less than 14, less than, like, let's say 20. There it is. Oops, I forgot to invert it. Negative sign. Ah, beautiful. Now I wonder what happens at this discontinuity. Well, I can make that work. I can make it more pleasant by raising this up a little bit higher. I don't want 20, I want like 19. Or no, I want like 18. Yeah, beautiful. Okay, now let's fatten this parabola out by making that coefficient smaller. If I do like 0.3, that's pretty good. 0.2, nah, 0.4, that looks really nice. Okay, great. And then finally, for x less than, 30, I want the equation to be like, well, I want to go down, so I'm going to have it equal, let me make it like 0.2x. There it is. Okay, great. So I want to make this negative 0.2x, but then I want to raise it up. So let me add like 10. Not enough. How about I add 13? Ooh, too much. 12. That's beautiful. All right, this is my grand finale. For x values that are less than 8, y just equals x. So we get this 45-degree angle line right here, where we go up to this value on y, which is 8, when x equals 8. But then, for input values between 8 and 14, y just equals a constant, and that constant is right there, it's 8. So we just ride right along, y equals 8, until we reach 14. And for those values, between 14 and 18, I've got a parabolic shape, a nice little quadratic function, so I hop up and get the star. And then after 18, for any x below 30, that's also greater than 18, I have a linear function, which is the rule connecting the x's to the y's is that the y equals negative 1/5 x plus 12, sending me right to the princess. You guys ready? Here we go. Psh, yoink, and success. I did use a quadratic here. Well done, you have saved the princess, your quest is over, and I feel so satisfied because I did use a quadratic in there, but I had a lot of fun. I learned a lot about how rules that connect numbers to other numbers can be shown graphically, and I learned a lot about myself today, and I hope you learned a lot about me too. And as always, thanks for watching.